We'll try to get through working group 3. We'll do a break when we can, and then near the end of the period, we'll do some frequently asked question tutorials were requested by some of you. Some of you don't need it, some of you may wish to. I got asked by 3 of you, so we'll meet afterwards. Maybe use this room or not, but we'll meet afterwards and go through some issues. And again, partly I'll give you some sort of preliminary what are frequently asked questions, and you can pick the ones that you're worried about or whatever. So we'll leave that one afterwards for, for basically for the SAT. Good. So working group 3. Okay, we're beginning working group 3. This is the 2007 assessment. What is working group 3? It's basically economists. Some are technologists, but it's mostly economists. Some policy people in terms of taxation, trade and cap issues, things like that. And so the idea is, what can you do to mitigate, and what's it going to cost? This is run by Bert Metz. Bert Metz has been running working group 3 for the last 3 assessments. He did it in 2001, he did it in 96. I remember him. He did it also in crazy kid when you're sorry. He did it forever. It's always been run out of the Netherlands. He always has these little green things, probably Dutch pictures somewhere. Okay. Sorry. So this is the summary for policymakers, which we're going to hit. And first of all, for perspective, I want to go first what happened in the third assessment report, which was 2001. Because it's quite a sort of, you'll see quite a bit of difference in style, capability. Working group 3 was always the poor cousin. Okay, the 2001 assessment report, we'll go through what they did for the summary there. So this was 2001. This was a summary for policymakers. Bert was again in charge. He's listed down there as one of the authors alphabetically, but he was the co-chair of the whole thing, and really in charge of it. And you can see the contents are fairly limited. You have a short table of contents, which isn't bad. And you have a bunch of words. You have, those are projections. These are basically carbon emissions following different scenarios. The gray and the red are a timeline of CO2 emissions, net CO2 emissions, following different stabilization scenarios. They're talking about what would it take to do it. If they stabilize, what do the emissions look like? So there's a small figure here on carbon emissions to reach different stabilizations. We're not going through it. Sorry, this is the blow up. Okay, so these are for the different SRES scenarios, and it's the implications of effectively what the CO2 equivalent would be. Actually, this may be CO2. This is not even CO2 equivalent. It's actually fossil fuel carbon. So for energy cycles. So they're worried about methane and tool and other things. There was a nice little figure in here that I used for a long time. 2001 was very useful. This one basically is an estimate of how much carbon there is. There were all these arguments that there was never enough carbon to do these silly IPCC scenarios. We're going to run out of coal and oil and whatever, peak oil, peak coal, whatever. And so what they did was to put together the left 3 bars, which are estimates of the reserves. Okay, and then the middle funky colored one in the middle is how much we've used to date of the 3 species, coal, oil, and gas. So you basically have, I'm trying to remember the order. We have conventional reserves are the purple, the conventional upper limits are white, and then unconventional reserves are blue. And that includes things like tar sands and everything else. Most of the unconventional reserves become reserves when there's enough money in it. Whereas conventional reserves are just what you think you can pump out now without doing much difference for what's available. And so conventional reserves have always been underestimated because people keep finding more stuff. But effectively, the left part were estimates for the 3 things, and you can see oil is larger than gas and coal is the biggest one of all. And then you look at how much was going to be used to date, and you have this tiny amount here. A little bit, this is what we've used to date. And then these are projected uses for the 21st century under all sorts of different scenarios that people said are unrealistic, and they say they're quite realistic. We easily have that much, but it's going to be coal. So if you look at sort of the total energy use projected on the scenarios, what's needed, it's going to be coal. There's plenty of coal around. It's not an issue. So it's actually a useful sort of figure reminder. The rest, they gave us one little funky table, which is sort of estimating. Again, we have the built environment, buildings, transport, the industry, energy efficiency, agriculture, waste. So this is all the big sort of sectors. And then what the emissions are, what you could get. And then working group 3 is not historical, it's really what you can get out of something. So the issue was on working group 3 of these columns, potential emissions reductions in different time frames. So that's one little table, okay. And then we had a bunch of other things, and we few words, and we ran out, and that was it. So that was the entire working group 3 in 2001, which meant that when we got to do the synthesis report in 2001, working group 3 was always the poor cousin. They had no information. They basically couldn't get their act together. Their models all disagreed. The top-down and bottom-up economic models were totally different. They had totally different numbers of what the cost of carbon was. Okay. And so in 2001, it was truly a shambles. And they were given one small question in the synthesis report. And basically, they had one little small piece. We gave them one question. We sent them off to do their own questions. Everybody else working with 1 and 2 sort of did the other 8 questions in the synthesis in 2001. So working group 3 is rather funny, okay. So now we go to 2007, okay. What's the difference? Well, we'll just scan through the summary, get a scale of what's in it versus what's not, and then we'll go through and look at pieces, okay. So we have our table, okay. Now suddenly we hit several things. We'll look at this. These are emissions, basically, historical, where they came from, what the sources are, what the gases are. We now have a bunch of indices. We have a blame game issue of what's responsible for different things. We now have another graph on the right, which is like the blue one on the left, is how much material is required for the different scenarios. Put in some blue boxes to help people misread or get lost. I think these are sort of, these should be footnotes, but they put in these boxes. We now have some real costing from bottom-up and top-down models on the right as to how much carbon you save by different taxations. Okay, you now have figures of where it's coming from, what the potential for saving by different industries are. Okay, again, very good things. And you end up with the same thing on the right you've seen before, which is literally sort of the total carbon coming out for different emission scenarios. And again, some other tables and estimates. Looking at the future, dividing up things by basically, looking at this one, which is various options for cumulative emission reductions, okay, and a fairly detailed table, and we finished there. So suddenly, working group 3 has come of age, okay? And you compare it to working group 2 that you saw in impacts and adaptation, now looks like a poor cousin because they have hardly any facts they can bring forward. Now suddenly working group 3 has their act together and they're really gung-ho. Clearly, it's a mixture of, became a hot topic in the last 10 years, a lot more research gets done, there's a lot more material, and then the community got a little more interested involved in saying, let's do it right and put the assessment together. So it's totally different from the one before, which had almost no content. And now they have all sorts of interesting information. Okay, so let's look at what we got. Let's see, we have an N box with uncertainties, which we'll look at later. Okay, so we start with greenhouse emission gas trends. Okay, it's not greenhouse gas trends; it's greenhouse emission trends. Okay, now there's a little bit of repeating here, but effectively between 1970 and 2004, the emissions have increased 70%. Okay, so now not the concentrations. Now remember, this is working group 3. They're the technologists, the engineers, whatever, the economists. So they're not worried, but the concentrations working group 1 is going to deal with. They're telling you what they've done on emissions. And so if we look at that, that's sort of a key result from 3, which isn't said anywhere in 1. Okay? And what's not brought back to 1 is whether or not this is consistent with the trace gases we've seen. So this is the one link that's missing in this whole assessment, is the sort of circle around, if we actually take these, does this explain 95, 99, 100% of the CO2 methane increase? They're projecting what they think the emissions have changed. Is that exactly what we see? Are there other natural things going on? Are there things we don't understand? What are the uncertainties? So this one really never got carried forward and back, unfortunately. So what do they go through? Okay, between 1990 and 2004, this is the increase from 28.7 to 49 gigatons. I looked at it and said, that's huge, that can't be right. Well, again, working group 3 is dealing with governments and other issues much more closely. They're dealing with the EPA reporting requirements, and they report CO2 equivalent, not carbon equivalent. So everybody in sciences does carbon cycle reports tons of carbon. These report tons of CO2, so it's 44 over 12 times as much. So I'm used to seeing fossil fuel emissions being 8, maybe 9 gigatons carbon. This is 49 because it's CO2. Okay, it's 44 over 12 times as large. So they're actually counting CO2, so that's the way they weigh it, which is fine as long as everybody realizes it and doesn't get caught. Sometimes I look at the numbers and just doesn't make sense. I have to sort of translate. So working group 3 will be dealing in the more commercial numbers of CO2 equivalents. Okay. And as a matter of fact, they're even, the classic number for the governments is MMTOEs, MTOs, million metric tons of CO2 equivalent. Yeah. Million metric tons equivalents, MMTOEs sometimes. Okay, that's what the governments often report. So if you see MMTOEs, that should be tons of CO2 equivalent. Okay. So now we have what's the cause. So we look at the growth. This comes from the energy sector. They say where it's coming from. They've identified the fact that you have a decrease in global energy intensity has made the growth smaller than otherwise. So they're looking at, do we get more joules out per ton of carbon? They're mixing that. They're looking at the growth of the joule, about the power industry, as well as the growth of CO2. So they're trying to arrange these factors and a range of policies. Okay. The last one's intriguing because it really says that you've got a whole bunch of things that have nothing to do with climate change. they're doing all this, of course. So, and including those on climate and energy security, sustainable development, et cetera, have had an effect. So it's not necessarily, this is not a response to mitigating the climate change, but this is what's happening when there's a threat of climate change mitigation. Okay? There's also issues of sustainability, there's issues of energy independence, all sorts of things are going online to drive these. Okay, so they're not trying to break it up and say what was responsible, actions. This is not an attribution issue at this point. So now we have a rather intriguing figure, which again focuses on emissions. So it's quite useful. It sort of reminds you they're all on the same scale. Okay, let's see, the scales are about the same on the left axis, but they're all gigaton CO2 equivalent. They're same units, and then the scales are about the same. So if you look at the top gases are the synthetic fluorinateds that we make. Refrigeration, car air conditioning is usually HFC 134A. These are all synthetic gases. We make them, they are very long-lived. Some of them are thousands of years, some of them are only 10 to 20 years. But in general, they are still small compared to CO2, but you can see the width. So they're not insignificant. You can see the little edge there, but they're not exactly the biggest worry about the issue, but they are part of the climate problem. Next is nitrous oxide, bigger chunk. And what you have is, again, split by sector. So the light blue on the top is other, famous whatever other is, and blue is agriculture. Other should be like waste handling and other issues. So where does N2O come from? N2O comes from all the urea nitrate and other nitrates we put out on fertilizers or that we process in waste handling, human and animal. Large amounts of nitrogen get together, they denitrify, they eventually form N2, but a lot of it comes out as N2O on the way. A small fraction comes out as N2O. So the object is get rid of all the nitrogen. You spend all this money fixing it into ammonium, so it becomes fertilizer, and then when you get in the waste handling, you have to get rid of it all again. Methane, again, bigger than N2O. CO2, the middle CO2 is land use. Land use change, forestry, things like that. So we have it split between decay and peat and deforestation. So it's basically land use change and forestry issues, which is not direct fossil fuel. So that will be recycled carbon, but it's this carbon we are enhancing. So this is the enhanced emission. And then the bottom will be fossil fuel. And other primarily on this is concrete and some other small things. Okay, making of concrete releases CO2 from limestone, basically. You bake it, get rid of the CO2, you form calcium oxide, that's the issue. Concrete, why? Okay. So it's nice to see this. It's fairly well balanced. You get to see the layout. Okay, it's nice to see the growth. Now these are emissions, again, not concentrations. So this would be nice to go back to working group one and say, does this make sense? Is this how much within the uncertainty is this what we see? Okay, this was not done. It'd be good. You see the growth rate. CO2 is growing faster than the others. Land use change has a blip. Now, why the years? Okay. Why do they do 1970, 80, 90, 2000, and 2004? Any idea why? So they gave us, four decadal numbers and then 2004. Any ideas why?
Didn't you mention that they couldn't go beyond 2004 for this presentation?
Oh, well, actually, they can go to 2007 if they can get published data. But it was written in 2000. It started being written in 2004. It was probably solidified in 2006 for final review. And getting economic data and putting it all together, probably the analysis weren't done in time. We barely get the temperature up to date. People are used to doing that one. So that's why 2004 is an odd year. Why did they put it in? Well, because you can see the significant change. I think they wouldn't have bothered fighting to get 2004 in if it weren't an unusual, didn't show the trend, but it does show continuing rise in use of energy and fossil fuel. And not so fast a rise in the others. Why only 1970? Okay. The atmospheric chemistry people want to go way back. They'll start the models running in 1850 and put stuff in. Okay, why do they go? And think about the economic data and the sectoral data. It's hard to start imagining things around 1970. Some of it's somewhat fictional. So how far dare you go back? These are what they consider robust. These are sort of the ranges that they think they trust. Same with measurements you see in satellites. Satellites really begin around 1960s, 1970s, so some of the measurements you see come online for climate are only for a given period. So in the same way, likewise, these probably do not have as good reliable data as you go further back. People will go back and do previous history, previous emissions, but they're much more uncertain. Okay. Now we look at something. With current climate mitigation policies and related sustainable development, global greenhouse gas emissions will continue to grow for the next few decades. Well, if you look back at this, it doesn't seem to be any stopping them. So what they're looking at now is what's going on now. We have climate mitigation policies in place with Kyoto in Europe, but we don't have them with the US. and we have sustainable development practices. So they're just looking at this is status quo. And then you see how they do things and how they judge uncertainties. And it's high agreement, much evidence. So you have a very nice little estimate of their uncertainty. Instead of saying this is likely, very likely, or extremely uncertain, they say high agreement, much evidence. So there's high agreement, no agreement, middling agreement, and then there's little evidence, much evidence. So I'm waiting for where there's no agreement and little evidence. I never found one of those where there's little evidence and no agreement. I was waiting to see where they actually did that. Fortunately, they didn't put in statements like that. You'd hope they wouldn't, because the statements would be a little bit meaningless. Again, it's a fairly loaded statement, but what's interesting in the paragraph that follows, it's fairly loaded, is 2/3 to 3/4 of the increase is non-Annex 1. Now remember, non-Annex 1 are the countries who have no obligations to mitigate under Kyoto. They include everything from the Seychelles Islands to China and India. Okay, and so this is a fairly brutal statement that got through there. I'm sure some of the governments didn't like it, but they could hardly argue with the facts. And that is that 2/3, that most of the increase in CO2 emissions is from non-Annex 1. And that's where the growth is. Now we have a bunch of crazy figures, which are actually quite intriguing. This is an index figure. Everyone likes indices, so there are no units. Units are sort of mentioned on the right, but basically it's an index. Everything's been indexed in 1970, and what they're showing are absolute changes and then ratios. But it's all been indexed to 1970 as being one. So the top line, for example, is income. So that's GDP, and I don't know what the PPP is. It's not per person, I don't think. It's to do with how it's calculated. What is GDP? Now, GDP PPP is how it's done. I forget. There's a way to do GDP that includes in-kind or not-in-kind ecosystems and other issues, and there's a way to do it that's doing strictly what they think they can relate to cash and money. So it's one way to do GDP. I'm not an expert on GDP, you'll get that elsewhere. Okay, but that's the total income. And then you have the total population, which is the green line under there. You have total CO2 emissions, the red line, and then you have total energy. And total primary energy supply is indexed in sort of like joules or whatever. Doesn't matter what you burn or what you do to get it, whether it's wind, fossil, or whatever, nuclear. And so you see everything growing. The population is growing less fast than CO2, which is not growing as fast as energy, which is not growing as fast as income. And so what you see is basically a world that's working on improving its lifestyle without linearly going as badly as it could. Okay, so we've gotten a better lifestyle. We have with less energy increase. Okay, global GDP. We've gotten the energy increase at slightly less CO2, and that's still growing up slower than the population. So then the other dashed lines are all various ratios. So it's a fairly good view for the 30-year period, 35-year period of sort of what's driving and what's been changing most. Responsibility. I nicknamed these are my two responsibility figures. Okay, there are two of them. Each one sort of shows a different aspect. So the question is, who's to blame for all the fossil fuel? So what you've got is strictly year 2004. This is not historical. So some people want to do this on the basis of total historical emissions. You could do a similar plot of historical. I don't know what you do for population, but this is instantaneous 2004. This is your total CO2 equivalent. So it includes the greenhouse gases, you've seen some before. And then it includes population. And so one of which is the tons of CO2 equivalent per person, which is plotted on the vertical axis, and then the other is the population on the right. So the problem is the size of the rectangle, not the height. In terms of climate, it doesn't care whether it's a skinny, tall rectangle or a large, low, flat one. It's basically the area of the rectangle, and the percentages are given in there. And so you can see that US and Canada are the big culprits in terms of tons of CO2 per capita, but their population is much less than the non-Annex 1 countries in East Asia, or even South Asia, which have much lower per capita but much larger populations. So this gets into the issue of being sort of, I would say, ethical neutral. Do you blame population? Do you blame per capita consumption? Doesn't matter. You can look at it and say, this is not picking one or the other. So it's a fairly reasonable way to do it. It allows you to sort of address the issues. I've been with people who view the vertical axis as the most ethical one, and others who view the horizontal axis as the ethical one. Sort of, you don't want to get into fights like that. The other one they gave was interesting, was the GDP one. Similar. Okay. One of which is the kilograms of CO2 equivalent per dollar in GDP using the PPP method. Should look it up, okay. This is in 2000 instead of 2004. Then the other is the cumulative GDP. of the country. You know, how much. And so once again, it's the area of the rectangle that matters. And you see basically countries that have large GDPs, the width of the box, but basically much, I would say, better energy intensity, less CO2 per energy or whatever. And then you see places like Africa and Soviet Union and other non-AX ones that are really terrible in terms of waste of CO2 per GDP, but really don't have much GDP. So it really doesn't matter. So anyhow, balance again is in the size of the rectangle, not the height of the width. So it's quite an interesting sort of perspective. It's nicely done in a way of being neutral. Then we have our similar figure on emissions. So this is the 2000 emissions, and this is not CO2. There's no equivalent. Effectively, this says what are your 2000 emissions, and then this says what are your projections looking like at 2100. So how much are they? And it's breaking them into different gases and whatever. So this is not the carbon available, but it's effectively saying what do you expect the emissions to look like. It's a perspective because all of these scenarios will be evaluated. So we have the 2030, the 2100. This group starts invoking the post-SRES, which didn't get into working group 1 and 2 very much because post-SRES scenarios, the SRES scenarios were the ones that working group 1 and 2 used primarily to do their calculations while the climate runs. Then post-SRES, well, SRES was 2000, but effectively, then they started looking at other scenarios, which are stabilization scenarios. And so some of these then had other, so post-SRESs are a range of stabilization, other scenarios, or optional scenarios to stabilize at a given temperature, a given amount of CO2. And so they looked also at what the emissions would look like for those. And so you'll begin to see other scenarios here that are stabilization scenarios that actually assume that climate actions will be made. The special report emission scenarios assume that there is no climate action ever. And as the governments wanted that, after that, the next assessment said, no, let's assume we make some climate action and stabilize at different levels. And the question is, what are the implications for emissions? So again, it gives you an idea of the range. You can see that some of the huge ones, some of them build up, some of them don't. Okay, baseline published since the res are compatible to those. So the other one is, is anything really unusual between the ones that we use, like the SRES scenarios, versus the ones that came afterwards? And the answer is not a lot. There's not that much of a difference. Okay, we have various boxes. This one talks about the scenarios. It redefines the special report emission scenarios, which was published in 2000. Everybody keeps putting this box in. Every SPM has the same box because I think people forget. I don't know why. Sort of a waste of a page. But then for this one, you have Working Group 3's problem. So Working Group 3 has a bunch of different things, which are sort of fun to look at and realize from the point of view of climate scientists. For some of you, this is more obvious. Okay, what are the issues they're dealing with? They need to define what they mean by market potential. Okay. Mitigation potential based on private costs and private discount rates. Okay. Now that's basically not the government's discount rate. The government can choose to not have a discount rate, but everybody else has to have a discount rate because they invest money to have to get something for it. Well, they used to. Okay, economic potential is mitigation potential takes social costs and benefits. So governments can deal with this. The economic potential base, okay, can be sort of a government issue. It's not a personal choice. You're saying, what are the net social benefits of these actions? So they're talking about the economic potential versus the market potential. One economic potential can be sort of government, large issues, market potential, sort of individuals, and small businesses. Then we have bottom-up and top-down studies, okay, which are sort of two different economic models. I think I'm trying to remember is this is taking the macroeconomy is unchanged. Yeah, bottom-up studies tend to be microeconomic models, and top-down studies tend to be sort of macroeconomic models. Set the whole rules. What does the whole thing filter down? So one literally says starts at the businesses and has little sims for businesses and people and say what do they do. And the other looks at the whole aggregate system and says how does it sort of shuffle. So I'm not an economist, but again, you should get somebody. We get somebody who works more on economics parts. Those two are different approaches. They've always disagreed in the past on this kind of assessment. Okay, now, short-term and medium-term. So they're going to look at the near term to 2030, and then they're going to look at 2100. Now, why 2030? Why is it so important? Do we have any figures in here? Okay. Yeah. The near term is really important because between now and 2030, or even 2007 and 2030, and now and 2050, you can hardly imagine any technology or whatever, or any improvement or significant change in technology having a large impact on emissions, climate, and whatever. Even if it becomes exciting and people suddenly get all their iPhones out and drop their TVs, the number of the people in the world who can do that, basically how long it's going to take to implement and change the infrastructure, it's going to take so long that it's hard to imagine a new technology making a major impact. Okay, coal-fired power plants go online for 25 years. Okay, all the new ones being built. If you're looking at new aircraft being built, it takes 15 years to start from scratch and get an aircraft certified before you can begin flying it. Once it's in the fleet, it lasts 40 years. Okay, so if you put in new aircraft in the fleet that are more efficient, it's going to take 20 or 30 years before you start slowly seeing a shift in the fleet. Same with all this stuff. So this big infrastructure issue was also up to 2030. You can have an idea of what technologies might be. You can sort of invent what maybe nanotubes might do for us to have an idea. When you go to 2100, you have no idea what the technologies will be, what would even be possible. So a lot of this work is done to 2030 for a good reason. You're sort of looking at, current world we know, you have some new experimental stuff coming out, maybe that'll change it by 2030 a bit, but effectively you're looking at a known world for technology, infrastructure, and even legislation. A lot of the clean air and everything else has stuff in motion. You can sort of get a feeling of what it's likely to be, at least to 2020 or so, and how it might shift. So there's a lot of work on this one, okay? And I like this both bottom up and top down studies indicate substantial economic potential. So this is the near-term mitigation potential. Now, so this is, table SPM1 begins with this table, which I'm pointing arrows down to a figure on the next page we'll get to, okay? This is the carbon price, $0, $20, $30, okay? And this is the economic potential, okay? And so this is the mitigation, and this is the gigatons of CO2 equivalent per year. And remember, we're looking now at about 40 gigatons a year. It's the number sort of for current CO2 emissions, CO2 equivalent about 40 or 50 now, about 49, 50. So we're looking at 5 to 7 for zero carbon, okay? And then the one below it is the global economic mitigation potential, top down. So the macro studies and micro studies. So you notice that the bottom up studies have $0 and they have a saving of 5 to 7. And you notice the top down ones have don't have $0, okay? You all understand why, okay? Anybody? Okay. What do the top-down models do? The macro models, they impose a tax on carbon, and they say, how does it filter through society? How do people respond? How do businesses react? How much is it worth them to save money? If you impose a zero tax, nothing happens to the current businesses. Well, if you impose a zero tax, are they going to change the way they're doing business now? No. Now, on the other hand, if you look from the bottom up and you look at what savings could be achieved at $0 or negative dollars, there is a fair amount of things that are basically disincentives, stupid and whatever, that we waste things on that if we chose not to, we would actually save money. So that's why you can save at least 15% by being smart. That's one of the problems here. Okay? You don't see it when you do the macroeconomic models, because if you impose a $0 tax, nothing responds to the model. You have to actually kick it somehow. From the bottom up, you start with the bottom up saying, how can each person improve this way? How would vehicles change? Okay. So the bottom up studies, the microeconomics will actually show you that there's actually savings to be had at no cost. And then they say, okay, now if I do this, how much does it cost me? So they're looking for what they can do and then saying, what's the cost? The top down ones are saying, I put the tax on, what do I get? It's slightly different. So now if we look at these, we get down to the figure on the next page, which actually has the same numbers. This is a bit silly. The table and the figures have almost the same numbers. Okay. And so they have a high and low end, they have an uncertainty range, so they have different models, so there's sort of some uncertainty level, they don't do a middle level. This is the $0, $20, $50 per ton level, okay? This is the bottom-up microeconomics, okay? So you see that gray area, you see there's a fair amount of savings with no level. And then if we look at the other one, on the right-hand side, we see the top-down, and we see similar results. What's amazing is the results are actually similar, which is quite surprising. Yeah, the dark green ones are a little bit higher on the microeconomic than the macroeconomic model, but in general, these results are surprisingly consistent with graphs we saw in 2001, which didn't even make it, which didn't make it in the Summit for Policymakers for a good reason in 2001. They were embarrassing. Okay. We went through the chapters trying to find something in 2001, and it was just chaos. These look impressively good. They don't agree, but they're pretty close. There's an understanding that both models are actually predicting the same system. Okay. Then we go through the details of issues of, let's look at, so we have energy, transport, buildings. And so we have key mitigation technologies currently commercially available, like you do today, and then projected before 2030. So again, this is from the bottom up. What can you do today to do it? And so these are technologies, so transport, fuel-efficient vehicles, biofuels, shifts from road transport to rail, that's obvious, rail and shipping, and public transport, non-motorized transport, which is cycling. Non-motorized, bicycling, okay. Cycling, walking, land use, okay. These are things that can be done today. Then you say, what can you do next? What do you expect in your next model up to 2030? Well, again, you're looking at technology which you can see. Second generation biofuels, you might understand how they can be made and processed and improved in a way to be more efficient. Aircraft, advanced electronic hybrid systems, okay, better, more efficiency aircraft and air traffic control systems, which are in place now, but would maybe take 10 years. You can see advanced hybrid vehicles, okay. As you go from gasoline powered to diesel, diesel and hybrid are about the same in terms of efficiency for use of carbon. And then if you make a diesel hybrid, you get another 20–30%, which hasn't been done yet. And then you have to do more tech, and then beyond that, you have to go to other odd things. Beyond diesel hybrid, sort of current technology, you easily see diesel hybrid moving in 5 years, up the Prius thing by another 30%. Okay. So these are kind of things to be done. So they're looking at what they do. Now, these are the things that go into it, and then they can sort of sum it up and say, what can we do? And those are the numbers you get by sort of pulling together. So it's quite a bit of detail. This breaks it down by sector. So this is gigatons per year, again, not cumulative. This is the gigaton CO2 per year. You would have savings. And the numbers below, I believe, that's the tax numbers. We're right. That's the tax numbers. So this is a macro model. Okay, this is 20, 50, 100. So this is from the top-down models. And they're looking at the different sectors. And so, for example, if you look at buildings, if you impose any tax on carbon, building efficiency, what you save from the buildings would be huge. Okay, insulation, things, all you can do in buildings, fairly cheap, easily produce carbon. Okay. If you look at transport, it's fairly tight. You get a little boost of that 1.5 gigatons a year from the transport system, but beyond that, it's price inflexible. Okay, there's only so much you can do to the cars, whether it's $20 a ton or $100 a ton of carbon. It's not going to make much difference, okay? Transportation, once it gets up at all there, then people will go to hybrids or whatever, just in fuel-efficient cars, you can do the best you can. Beyond that, you're not going to get much more, for example, on transport. And then there's the issue about transport was not broken down, but other were broken down into OECD. Economies in transition is former Soviet states, of course, and non-OECD, non-EIT is basically the rest of the world. Okay, and so they broke it down into where the savings could be accomplished. So for agriculture, you don't see a lot of savings in OECD. You see some, but you see the rest of the world as being very inefficient in agriculture. And if you basically had a tax on it, agriculture would become more efficient when the savings would be greater, for example, in the developing world. Again, they're trying to look at the sectors, what's happening in different countries, and so the models are quite complex, but they're dividing out. This is actually quite an interesting figure. There's a lot of information on in terms of how stiff is the response, what's the amount. Transport, I don't remember why it wasn't broken up, but I'm almost sure because transport right now is international. Okay, everybody's making cars to meet the EU5 specs. All of Chinese cars, which are above the EPA specs. Nobody's making cars that are inefficient in one country because they can't sell them in another. Airplanes have to be everywhere. So most all of transport tends to be fairly modern. Shipping, international shipping, all runs super high efficiency diesels. Okay, put out a lot of NOx, but they're very efficient. Okay, so there are all these things that mostly transportation you couldn't attribute to a country because most of the transportation knowledge and base and what the technologies are would basically uniform. Okay, so let's see. Macroeconomic costs for multi-gas mitigation are estimated between 3% decrease in GDP and a small increase. So this is the big fight. Oh, gee, we can't do this because it's going to kill our economy. So then you start looking at what's the cost of doing this. If you impose this, what's the net cost? And so they gave you this number between a 3% decrease in global GDP, which is terrible, except given the last 2 years, it may not seem so bad. That would be the only problem we suffer. And then a small increase. So some people actually get an increase in GDP when you force basically decarbonize society. Okay, this goes back now to stabilization levels. Okay, so we're now looking at cost in terms of stabilization. So this is, let's see, goal economic cost, least cost trajectories. So least cost trajectory means if you're going to stabilize at some number, you don't go way up and go way down, but you might overshoot a bit, come back a little bit. You don't force it down immediately, so you take time. So things, you allow the plants to live 20 years and then you get rid of them. You don't kill them all off immediately. So you're picking a sort of most gentle cost-wise. And so then this looks at the median GDP reduction. So this has been the great battle. And so you have the range. And what's funny is I can't tell that range. I think the one I circled in the middle is like minus 0.6, minus 1.2. I think it's minus 0.62 plus 1.2. It's a very bad laid out table. But they mean it goes from minus 0.6 reduction, which is an increase, to a 1.2% reduction. And that's for stabilization between 590 and 710. Why do they have those numbers? Because everybody runs these complex models and they stabilize and they're not really sure what to plan what they're stabilizing on. And then the model stabilizes. They say, okay, so they say for this range. So then they group all the model results in clusters. So not everybody was forced to stabilize at 600 parts per million CO2 equivalent. They just ran their model to get close to something like that. And they said, okay, so we ended up stabilizing, we think, at this level. And so what they do with all these little spaghetti lines is then they cluster and say, okay, this group is between 590 and 710, and then you have the 535, 590, and so on. And so again, this is to try and estimate what the cost would be, which is a very big topic, it's certainly very popular in administrations. Okay. Then we go through a bunch of fairly numbered bullets. Now, one of the things I want you to note on this is that this, so this is page, we're already past this page, must be the previous page we're on then. Okay, the previous page has 7. You'll note that the paragraphs are numbered. The big paragraphs are numbered. The bullets are not numbered, but the big paragraphs are numbered in this. I like it, it's wonderful. I mean, if you're writing, at least you can refer to paragraph number 11 and know what you're talking about and who's responsible for it. Otherwise, working group 1 didn't number anything and there's just chaos. And you say, well, what paragraph is it? Well, it's the one on page, this line, that, which version do you have? So, I'm sorry, these guys did a very nice job because numbering really helps. There's no reason why they shouldn't be numbered. It's very helpful because at least both referring to it, whatever. So, number 7 on the previous page goes on, we'll continue. Changes in lifestyle behavior and contribute to climate change, management practice, positive role. These are all sort of the favorite things, studies, different methodologies, all, let's see, near-term health co-benefits from air pollution, okay? Be substantial, there are good things going on. Fossil fuel exporting nations, Annex 1, Annex 1 we expected, target lower demand prices, GDP growth. Okay, this is where Saudi Arabia constantly makes noise at the Framework Convention because they claim that they are going to suffer greatly, their economy will suffer greatly because of mitigation, because that will lower the price of oil. Probably won't, but anyhow, they're claiming that people using less oil is damaging their economy and the world owes them reparations for it. I don't want to go there, but this is one of the major arguments they always raise, that they and some other economies are going to suffer greatly by this, and therefore climate change treaty has to deal with that. So it's like the reverse of if we don't do anything, people are going to go into water. If we do something, these other countries will suffer. And so that's why this is brought out here. Let's see, vocational transport sector. Again, various mitigation options. I love the bottom. Faced with barriers such as consumer preferences. Consumer preference seems to be a barrier to common sense in CO2 emissions from vehicles. It's a very nice statement. I like it. But that is one of the greater barriers. Okay, we certainly see it in California. New and existing buildings are a really big issue. That's a great chance. Paragraph 12. Okay. Economic potential in the industrial sector, predominantly energy-intensive industries. Okay. That would be things like making aluminum, things like that, the ones that have high energy use. I'm not sure whether paper making is high energy or not, but okay. Full use of mitigation options not being made either industrialized or developing nations on these. Okay, agricultural practices, again, they're trying to do that. Then there'll be bullets underneath these is what you get out of each. Forest-related mitigation. This has to do with, again, trying to make sure the forests keep growing and you keep producing biomass, even if you don't harvest its trees, but you don't lose it, and basically lose a lot to the air when you harvest. So you make wood products, it's not so bad, but if you don't make wood products and just scrape all the excess trees off and then burn them, then you really have lost what you put into it. Post-consumer waste. Again, this is a small contributor, but again, positive contributions. Post-consumer waste is landfill and other issues. Okay, a lot of methane comes out of landfill. If we grow trees, cut trees down, put them in landfill, and they decay to CO2, it's a net neutral because we just suck the CO2 out of the air and the trees, and then we put it back in a few years later in a landfill. But if it comes out as methane, then for 10 years or 20 years, it's looking really much worse. It has about 20 times the impact of CO2. And the other things about landfill are other nasty things, maybe N2O and other things. So landfills produce other things other than just letting it slowly rot. Okay, mitigation in the long term. So then you go post 2030 and now it gets a little flakier. There's a lot more information, and then we get into this. There's a big geoscience engineering thing that came out of the Royal Society a couple of years ago. If you don't have fun, you can read it. It's available on the web somewhere in various places in PDF. It goes through all the issues. They actually did a very good job of this one of objectively evaluating them. And if you want, if we have a chance, we'll talk about it at some point. But the geoengineering one was an interesting thing. Does anybody recognize the picture on the front of the geoengineering planet? Do you know what that one is?
Okay, thank you.
What?
Epcot Center?
No, it could be, but it's not. It's actually Lovelock's Daisy World. It's where the world is a mixture of black and white daisies, and they can propagate or grow next to each other like this. And the white daisies reflect sunlight, the black daisies absorb it. So the question is, how do they mature and balance each other to make the planet in balance? So that was an interesting choice for geoengineering, was to do Daisy World. So if you look up Daisy World, you'll find it. Okay. Geoengineering options, fertilization, and so on. Okay, blocking sunlight. Reliable cost options. These have not been published. No kidding. Risk, unknown risk, and side effects. No kidding. Okay, nobody really knows what's going to happen if you do these things. It really hasn't been done. And a lot of the cost estimates people have done are totally flaky. They're just flying another jet up there and dump some salt in the stratosphere. It's really rather lightweight. This is a key issue that primarily is regarding to CO2, but other ones, that greenhouse gases are out of balance now, or they're climbing. Okay, methane's not, but N2O and CO2 are. What you have to do to stabilize is not freeze emissions, but to freeze emissions, turn them over, and then drop down to a lower level. If you freeze emissions, the greenhouse gases are going to continue to grow. And so this is basically, we're out of balance. If we continue to, it'll take a while longer. They'll eventually go in balance, but they're going to continue to rise longer. This is a warning. You've basically got to cut. This gets to this issue when they'll evaluate emissions that go up to now, continue to rise a bit because of the economy, physical plant, whatever. Then due to technology or other actions, will slowly turn over and come down. So the emissions they'll look at, you'll see pictures of stabilization and what they involve. Okay, so this is again year for peaking, so when did the CO2 emissions peak? And so that's why that paragraph 18 is leading up into all of these future scenarios post-2030 that the working group 3 is going to analyze for how do you get there from here. There are many different pathways as to how fast you peak, how fast you turn down. And I think you're going to see the pictures. Here's the picture option, okay? Emissions pathways of these mitigation scenarios, which reflect stabilization, okay? Range of stabilization. Portfolio technologies currently available, expected personally. Okay, so they're just saying there's many ways to approach this. And I didn't blow this picture up, sorry, because there was another one earlier. The pattern here, sorry. This is just the history of emissions, and you can see there's sort of a range. Each one saying I'm going to stabilize at a different level, and so each one has sort of a band of emissions. The thing that's misleading about that curve, if you look at the one on the upper right, which is a little fuzzy, yeah, it's not too bad, it's better there than here. You notice it pinches together at the middle and then gets wider. Well, what you're seeing is one that's actually going under and then crossing over and going above, and the other goes up and goes down. So it's a little misleading about the envelope. You really should see the individual lines, because you can't take the undercurve of that. The undercurve is, it's the total amount you emit that matters, and so that one on the upper right is sort of a little misleading. They don't all suddenly agree at that point. Literally, one took a low ball number to start with and pushed the industry down, therefore they can emit more later, and the other let the industry continue to emit and therefore had to cut more later. So anyway. This is a complex one, but this one I still have trouble with. They're going to do groups 1 through 5. Now, what 1 through 6, Roman 1 through 6, I don't know what they are, it doesn't really matter, it's just their groupings of them. We're going to discuss what happens in each one. But these are stabilization. So they stabilize at a given level, so they're going to look at, say, looks like 440 to 490, group 1, which is very low level of CO2 equivalent. Note that it's CO2 equivalent. Okay, right now we are at 400 ppm CO2 approximately. Okay? If you add methane and everything else, we're well above 450. So CO2 equivalent, we're already, CO2 is here, and then the other gas is out here when you add one. So we have to deal, CO2 equivalent deals with methane, tropospheric ozone, nitrous oxide as well. So they're going to look at the range of that, and then they're going to say, what is the uncertainty range in temperatures? And again, the range in temperatures comes from working group 1. So it's saying if we stabilize, what's the height? If we stabilize a given CO2, what's the band? What's the temperature range? And so they're looking at, for example, at 700 ppm CO2 equivalent between the 4 and the 5, looking at about 3 degrees to 6 degrees. Sort of the estimate range. This is not a real uncertainty estimate, so I'm not sure quite why they did this, but it's to remind you, because now they're going to use these groupings to look at costs and whatever. They're not going to do damage assessment. It's working group 2. They're doing cost in terms of what it takes to get there. Then they have this blow up here on cumulative emissions reductions for alternative mitigation, in the right panel. So this is trying to say how much you might save under some of the under these various models for stabilization. And is this, let's see, mitigation measures. Okay, this is the 490 to 550 CO2, so that is the 495.50. So that's the yellow band, Roman numeral 2. So for Roman numeral 2, trajectory, okay, this is an example from Image, Message, AIM, and IPAC are not obscure. They're just the acronyms for 4 integrated assessment models that they use to play games with and run these out. Okay. So they're saying, how do we get there, and what does it take for emissions reduction? So now they're looking at the short-term period and then the longer-term period. The reason why the longer-term period is bigger is because it's integrated for 100 years. The short-term one's integrated for 30 years. So it's cumulative reduction in emissions you have to accomplish. So they're looking at where you can get it from. So these models are being tweaked to match the stabilization, and they're being pushed and tweaked, and so they're saying, where do they get it from? And so you can see energy conservation efficiency is responsible for a fair number, okay? Then we have fossil fuel switching. That would be from coal to gas to oil type things. Renewable energies, it sort of depends, okay? And so on. So this is an idea of where the model, so they're trying to drive these models in a way and then say, what in their model, where did they get it from? They're forcing it, they're running a scenario that gets to the stabilization roughly in that range. And they're each then comparing what they get them from. And you can see the models are sort of in agreement, sort of not, depends on whether you consider good or bad. The short term's more similar. Why? Because there's only so much you can do in the short term. And the long term is much more haywire in terms of how they get the savings. Okay, macroeconomic costs for multi-gas mitigation. And then again, it's always in terms of GDP. So this one, to go towards stabilization between 450 and range from a 5.5% decrease, that's if you force it to 445, you're really pushing CO2 way back, and that's fairly tough. Okay, and then you have decision-making about mitigation over time, involves iterative risk management, the co-benefits, okay, sort of a motherhood statement. Choice about scale and timing involve balancing economic costs, more rapid emissions reductions, okay. There's nothing new on that, but sort of reminds you about all the worries they have. And then again, they talk about another GDP for this, for the stabilization. Policies and measures, okay. It's interesting. It sort of says, now you get into how can this actually happen? What does it take? So then you start worrying about, it says policies and instruments available to create incentives for mitigation, but it depends on national circumstances, non-retaining circumstances. Experience and implementation shows their advantages and disadvantages for any given instrument. That's the most nonsensical statement I've ever heard. I mean, it says, gee, there are many things you can do, but we don't know what to do. And there's no clear evidence that one's better than the other. Well, so we have different places. It's a mother, I don't know how they crafted that one, but it's very funny that there's much evidence and high agreement for a statement that doesn't have any solid, really. I don't know what the conclusion is. It says this could be A or B. Yes, okay. I want to get to that. Then it's a little bit better. Real or implicit price of carbon could create incentives for producers and consumers to invest in products and technologies. That's obvious, but that at least comes out of their models or their little sims that they're running around. Okay. And then we look at this table this table looks at the sector, the policies and measures to be shown environmentally effective, and then key constraints. Okay. So now you're looking at, they're going sector by sector and saying what do we think could work, and then they, on the right are basically the disincentives, the failures in the system that basically make it better to burn more carbon and save it. Okay. So for energy supply, you have reduction of fossil fuel subsidies. Taxes on carbon, there's a lot of subsidies. Fossil fuel use is subsidized heavily in many places. People are paid to use it extra to get money by using it, okay? There's a resistance in vested interest. That is, you actually pay less than the cost of mining it. Okay, there's resistance by vested interest, of course, because oil companies, ExxonMobil has a vested interest. Okay. Transfer of technology, public benefits, then they talk about the public benefit of R&D spending, research and development spending. Okay. I love this one. Notable achievements of the Framework Conventions, Kyoto Protocol, the establishment of a global response to the climate problem. It's a little bit silly. Stimulation of array of policies and creation of interface, market, and the establishment of new institutional mechanisms. I think it's a little bit pushy to put this in an IPCC report, but whether it's truthful or not, it's interesting. I mean, it could be objective. What they're saying is, I wouldn't call it notable achievements. You'd say, one result of the UNFCCC and the Kyoto has been to do the following. I think this one's pretty silly. Delegates were very proud of themselves, and they want to make sure the Framework Convention thought that, But the issue is, has the Framework Convention started things changing in some countries? Yes, it started changing attitudes, the recognition of climate change. Has the Kyoto Protocol also started things going, even when it hasn't gone into effect, even before? And the answer is yes, it has, because people are thinking about what could you do, and they might start acting that way. So it has set up, moreover, goals, mechanisms, game playing, and carbon market, which will allow people to start playing games and find out what happens if. So it started opening up the economics and the technology response to start seeing if you start applying pressure, do you see any action or not. So it's actually giving them more information than they had, before 1995. There was no pressure on climate, there's no issue. Now you start seeing it, so it has actually changed the response to the system. So I think in that sense it is interesting. I don't know its notable achievements, but I guess for the economists, I shouldn't be an economist. Making development more sustainable. Okay, changing path can be a major contribution. Again, sustainable development is brought in. Okay, and finally it ends with more research, please, which I found working group 2 and 3 did, working group 1 didn't. Additional research addressing these gaps would further reduce uncertainties. Okay, it's sort of funny, but of course it's like obvious or not. I mean, I guess the idea is we have no more to learn, so you're stuck, or we still have more to learn would be the answer. But once again, it looks like the usual, send more money. And that's the end of it. Again, paragraph 28, large paragraph 28, there are bullets underneath them and so on, but fairly well laid out. So, fairly complex, a lot of mix from different styles of economics went into it, seemed to survive. Okay, it's not too bloody. Questions? What do you think? That's the end of it, yeah. How's this table here? Right. Any thoughts? Similar authors, okay. What is designated by their country. I've never figured out how they do the countries, because sometimes if your Guy Sir was Belgian, but he always worked in NCAR for the longest time, and therefore he was listed as the US. It really depends on where you're working, not your nationality. It's actually where your professional affiliation is. That's who pays your job, that's who pays your salary, so that's what they list you by. Okay, again, a broader table of contents, more detail, broken down into all sorts of, again, the sectors, energy, residential, industry, and so on. And then back in the whole section on policies, instruments, and how things might get done. Gaps in knowledge is our favorite. Gaps in knowledge is the same thing as robust findings and key uncertainties. Everybody has a little table in the back. They're told to put their technical summary saying, what are the major gaps or what's your robust thing. So let's not worry about the content. Yeah. See, they do remind you here, total CO2 equivalent of all greenhouse gases is now about 450. Okay, this is 2007, 2006, okay. So we're well above, we're well above 450 already. We have cooling of aerosols, okay. You get a slightly different chart, which is sort of fun. Mind you, it breaks the whole total up into the gases, which is sometimes useful. I mean, TS1 is a useful figure to have in terms of where they're all coming from. Notice that the CO2 has 3 different colors, fossil fuel, the other being sort of cement, other industries, and then deforestation, land use issues. So it's a nice chart. And then we get to the next one, we get a chart broken up by all the gases together now, weighted by CO2 by what industry, what sector. And so it's, again, fairly useful, simple little charts that are actually quite valuable. It would have made the SPM in the old days, but the SPM is so full of stuff right now, it didn't make it, so these are actually quite nice ones that can surface. I find useful, let's see, some of these factors. So this is the GDP ones, we're not getting there. This is this is a very complicated matter. What boosts the GDP? What costs the, so there's population, what caused the change in emissions in gigatons? So this tries to blame population, GDP, energy efficiency. And so you see energy intensity goes down, that's reducing emissions. Population is adding on to it, the yellow one. The increasing income per capita, the orange one, it's going up. This is the driving forces in the different scenarios of what people did. So the left is observations, that's history. I won't call it observations, it's historical reconstruction. And then the right is an estimate of the future of what's driving it. It's a fairly interesting little figure. When you dissect it, it's complicated. It's like sometimes the figure in the paper, it takes forever to sit there and read for an hour. This one literally is trying to do the driving forces decade by decade on the emissions. What caused the change? And so you can see, we have that population, whatever, and then the net change is the dashed line. So yeah, that's quite a fun little figure, sort of recognizing what the driving forces will be, whether it's population, GDP, or whatever, or energy efficiency, which is improving. Some other things, please let's skip some of these. Article 2 of the Convention of Mitigation, dangerous anthropogenic interference, what level is anthropogenic? So they start discussing it in here. Decisions made in relation to Article 2 would determine the level of climate change. It's a policy goal, but there is no real policy goal since we haven't chosen the level, okay? So they're talking. Judgment on dangerous interference is social and political one, depending on level of risk deemed acceptable, large emission reduction, unavoidable stabilization to be achieved. So they're getting around the issue that they can't answer Article 2 of the Convention, which is what is dangerous anthropogenic interference and how do we keep just below that. They're pointing out, again, they don't know how to do it, so they'll do a whole bunch of stabilization scenarios, which is the only thing they can do, So it's hard to determine what is dangerous. Unlike working group 2, which took on in chapter 19 was dangerous. I've got a whole bunch of issues here. Skip that one. There's some fun figures in here. Top-down, bottom-up study. This is from disembodied knowledge. This is technology development cycle. And we're going out. Some of these figures were very bizarre. What's private sector, what's public sector, how things get put in. This is an example of the SRES and pre-SRES scenarios, non-intervention scenarios. And so what they do is they have a whole bunch of lines. This is the gigatons of CO2 emitted in those various scenarios. And all they do is sort of then cluster them as a group, call them this is this type, this is this type, it's associated. Certain ones are different patterns. And so it looks like that spaghetti plot. So that's the range of scenarios that were considered. But these are the non-intervention ones. The intervention ones will assume stabilization. That requires you to mitigate. These are the ones that don't have enforced mitigation. They may have voluntary, but not enforced. Again, you get various ranges here, and then this is this range of how much emissions you could have. They looked at the tar range versus the modern range. Okay. Then you get panel. This one's even weirder. This is the panels give the costs as measured in GDP loss. And so it's a whole bunch of models. Up against the left is keeping CO2 way low, so the cost of GDP goes way up. Down to the right is allowing CO2 to go 700,000 parts per million. That doesn't cost so much. You just have to mitigate a little bit. So again, sort of this hyperbolic curve. And again, what you see is the scatter plot of all the models. So this is, fortunately, what they didn't put in the SPM. This is a whole range of results. So you go, okay, what are we supposed to get out? Except that basically the curve looks sort of like a hyperbola, as you might expect. If you force CO2 to be below 450, it's going to cost an awful lot. Because you have very little choice on what you can do, and you're forced to really cut down things that are very expensive to do. Again, that old chart you've seen before. This is primary energy consumption. And I'm trying to think what the years are. This is the historical ones. This last 30-some years, 71 to 2003. I found this one interesting. It's a little hard because it's sort of assembled weirdly. But it's by region. It just shows the energy growth in terms of summing total energy was electric, also heat, whatever. And of course, see the Asia growth rate versus North America versus Europe, which is flattest. ECCA, countries of Eastern Europe. Okay. Yeah. That's like economies in transition. Soviet Union, they dropped in the 1990s, of course, when Soviet Union collapsed and all the old energy things. Now they're picking up again. It's replaced by energy products. Okay. MTOs, very funny. Okay, that's the energy one. Okay. These are the sources. You can see again projections out. This is historical, and then the projection issues. Okay, some of the figures in here are interesting. Most of them. Go through the tail of them. Problems, worries. Okay. Cooling conventional nuclear power plants may become a problem if rivers and lakes are warmer. This points out that there's always these issues going on. Nuclear is going to have a big problem because nuclear needs water cooling, and water cooling may become more difficult depending on where you put it. So it's not a panacea automatically, at least the current set of plants that need a fair amount of water cooling. Okay, so that's one of the problems with nuclear power. Integrated non-climate benefits, co-benefits of greenhouse gas mitigation in the energy sector are substantial. So this has to do with health and other benefits. Innovation, technological innovation, air pollution abatement, and so on. This one's great. Current transportation activity is likely driven by internal combustion powered by petroleum. Okay, 95% of the 83 exajoules in the world 95% of the 83 exajoules of world transport energy use, internal combustion engine. So, of the 83 exajoules, it's the energy used by the transport system 2004, 95% come from the internal combustion engine, pistons, diesel, doesn't matter. Grow robustly, this is my favorite. Okay, this is the vehicle ownership per 1,000 persons, and then we have the GDP per capita. So obviously the wealthier countries have more vehicles per person, and you see the US one. The vehicle used per 1,000 persons is almost over 1-to-1, but not quite. I'm not sure which way these things are going. New Zealand suddenly popped up, but basically you can sort of see where everybody is in that list. The anomalies would be things like Denmark and Netherlands, which are high in the GDP, but low down at the bottom, because of public transport, basically. I mean, if you had really good public transport, you might need 1 car per family, but not 2, for example. And so that's sort of what you're looking at here. Like which 1 car per family? Global aviation's always a problem. Okay, this is trying to mask air, sea. I'm suspicious about this because I think the maritime one is much larger. I don't know where these data come from. But we've been working on quantifying climate impacts to the emissions of ships and whatever. ship use is much larger than aviation use. I don't know what's going on with this figure. It shows it being smaller. It's very shame. Maritime use is much bigger than I remember on this one. But again, that's sort of the transportation sector breakdown. Now, comparison biology. This is the cost. This is sort of has to do. This is a fun one. Forget. This is the estimate of the cost per dollars per liter, and currently and in maybe 2030 with new technology and with things that are envisaged now or even available in sort of pilot plants. So the blue is the dollars per liter. You can see you're approaching $1 per liter for ethanol. It is totally inefficient. The price on the left is gasoline and diesel in terms of $1 per liter. Okay, so ethanol from cellulose today is very expensive. That's the far right. But even ethanol from maize costs, as you can see, about 30% more than it costs from oil or diesel. Okay, it's a very expensive way to do it, and it also uses up a lot of fossil fuel to do it. On the other hand, if you can get cellulosic, you might bring it down at best to something around that level. So the issue is, what are the costs of all the alternative fuels for the transport system? It's a fairly detailed look at those. Then biofuels are given a problem. Animal fat is cheap, but there's not a lot. And then you go to plants for biofuels, vegetable oil, and then Fischer-Tropsch synthesis is where you actually make synthetic diesel with a lot of energy and whatever, and that's very expensive. So there are various ways of looking at the approach. What they didn't look at is, there's somebody's done this, is literally how much is available in each of these. So sugarcane, Brazil makes ethanol out of sugarcane, okay? They're already at the super efficient level with the blue line over there for the first line on corn. This is basically sugarcane, and you can probably get down to here. And so Brazil is very efficient. They run a lot of cars on ethanol, okay? They have no problem with it. They make it. The sugarcane's made. They know how to run a very self-efficient process. They use the bagasse from the sugarcane to boil the thing. Everything's done. Sort of self-contained small process unit. It's very efficient use for making transportation fuel. The U.S. does it from corn, which is really dumb and inefficient. But we don't have sugarcane. We also don't have the ability to have much better expertise on this. So if you look at sugarcane, it's possible, but even then, when you look at sugarcane, this should be normalized. You have to be careful because ethanol is really lousy fuel, okay? And so ethanol has about 70% of the energy that gasoline does. And so ethanol fuel should be priced 30% less, but they're not. And when people go to Brazil, I know people in Brazil, the embassy down there, you look at the price of the pump, they said, okay, we have to take the gas price, multiply by the ethanol price, and see if it's 70% of the gas price or not. You start seeing, because the car burns both. You either put it in the tank, you put either one in the tank. So they look at what the price is, and they decide whether the ethanol or the gasoline is the better price. And you basically take the ethanol price, realize it has to be much less. Okay, marine transport, okay. Marine organization, combination of technical management, ship emissions, okay. Again, ships are getting faster, more efficient, but they're running faster. The problem is the faster they run, twice the fuel they burn and so on. So the issue is, the latest route is for maritime because of the cost, is ships are going slower. They're just saying tough is going to take an extra 5 days, 3 days to get to port, but they use about half the fuel and run across the Pacific. Yeah.
Oh, just going back to that other graph, did they have a projection of future costs of oil, gas and diesel there? Or is that just current?
That's current.
Okay.
And I don't know why the range. I think this may be the actual cost of, see, that's the production cost. And so production cost for stuff that's easy to come by and easy to come out, that's fairly pure, easy, it's not too nasty crude and whatever, sweet crude, or the cost might be down here for current pumping. Other places where you're extracting it from more difficult places are up here. So they're actually using a range of numbers that the industry says of what it costs to make the stuff. And it varies depending on how easy the field is and how easy the crude oil is. So that's sort of the spread. Okay, these maps are a hoot. I found these very fun. They're interesting. They put them for all sorts of things. The residential map. And so this is the emissions of CO2 from buildings, including from electricity use in the building. So this including emissions from the use of electricity. Okay, they go into powering the building. So if you use electricity to heat the building, it's part of the emissions they use for. And so this is sort of the fun one. You get the past in red, dark red, the future, next 30 years in sort of orange, and you have all the countries, all the sort of regions summed up and estimated. So it's actually very interesting, quite an interesting graphic. The table would work, but the graphic's sort of intriguing. So it takes a little while to get used to it. So again, we're running the last 30 years, the next 30 years. So the same period, past 30, next 30 from 2000 versus 2007, right? And you're looking at sort of what are the building costs. Okay, and they do similar ones for other gases. This is, sorry, this is silly, building ones. Industry does a similar one, status of sector, energy intensive industry. Okay, energy intensive industry, iron, steel, ferrous, and so on. Those are the ones that fuel use, okay. Most of the energy intensive industry is now in developing countries. Okay, it's been shipped off site, okay. So that's where a lot of the energy comes out, a lot of fossil fuel. We have exported our greenhouse gas emissions. This is the energy sector, okay. And so you see non-Annex 1 East Asia, which is it's huge. There's a lot of production here. North America is flat. Latin America is even spinning up predictably. Non-Annex 1 South Asia is going up. Pacific, this is New Zealand, flat. This is production of steel, aluminum, everything else. Okay, why is it flat? Because it's being imported. It's not because of using this. Okay, projected industrial sector emissions. Okay, developing Asia is huge on that, once again, for the industry sector, which is all manufacturing. Let's see, climate use of available mitigation options not being made in industrial developing nations, okay, and so on, once again. Warning, things aren't working, co-benefits are raised again, agriculture has theirs, again, a picture for agriculture, whoops, so the graduate does. Okay, slightly different picture, but not bad, from 1990 to 2020, I don't know why agriculture was done differently, but this is N2O methane. So it's looking not at the CO2, but looking at the other gases from agriculture. Because the agriculture sector is effectively the main emissions of methane and N2O. And again, depends on growth of the sector. Let's see, this one is potential for greenhouse gas mitigation in 2030. So this is the total, this is the saving in emissions. That was cumulative, it's like it's instantaneous. Potential for, megatons, not gigatons CO2 equivalent. So this is, we were looking at gigatons. This is megatons. So you put the decimal in. So it's going from 0 to 1.4, 1.2. Out of 50, okay? This is the annual savings. So again, slightly different use. Again, looking at different regions, so this has to do with what the cost might be if you tax carbon and what you get from cultivating soils, cropland management, and different agricultural practices. Again, fair amount of effort on the ag sector on this one. So this one, for example, Working Group 3 had a lot of work on the ag sector from the point of view of practices, costs, and whatever. Working Group 2 tried to put together the impacts and adaptation on the ag sector, but did not get as far as this one. But this is a lot easier. These numbers are already out there. For the cost of doing business, they've been out for a while. The cost of a 1 degree rise on your crop is not well known, so Working Group 2 has a much tougher thing to get back. These are all part of everybody's accounting sheets. So you sort of estimate how much you could get, then you make an estimate how much you could save. So I'm not sure. I don't trust those numbers, what they're getting them from. How do we know that the management's really going to work? But these are, somebody's out there, somebody's published, there's a couple published numbers on what you might get from changing, if you don't lose as much soil, what you get for saving carbon, okay? They're saying what the cost would be to make people do that, and then they immediately plug a number in. The numbers on these are pretty uncertain. Especially this stuff, it's really hard to, energy use in fuel and transportation, that's pretty robust, but getting the ag sector numbers, long-term outlook, let's see, let's get down. Forestry gets its niche, you get a whole thing of forest use, okay? This is the carbon balance due to land use forestry issues, so you can see that some places, the US claims we're sucking it down because we're reforesting areas, so building up more cellulose. Other areas are still deforesting and turning it over, okay? Let's see, economic mitigation in the forestry sector, what can you get by region? And this is the case where your top-down, bottom-up models, your micro and macroeconomic models don't really agree. Okay, so there's quite a large difference on how much savings you think you could get. Okay, and this is for up to $100, basically $100 a ton of CO2. What you would get from the forestry sector, and so some people think, you know, for the bottom line, they really, in fact, less than factor two agreement from the two approaches here. This goes back to 2001, so what everything looked like then. Clean development mechanism. Despite low cost, afforestation, not many activities yet implemented, a number of barriers, including late agreement, complexity of rules governing. Okay, remember the clean development mechanism was set up under the Kyoto Protocol. It was for Annex 1 countries, the rich countries, to buy their credits from setting up, save the forest, save the hectare, or change a plant, or change waste handling to reduce greenhouse gas emissions in the developing world. The developing world had to propose them, issue a price that they would sell them for, and agree to set them up. and then have them certified by somebody in Switzerland that yes, indeed, they were going to be saving this much greenhouse gas emissions. They're fairly complicated, as you can imagine, because from a number money going through the system, so people are a little nervous about who certifies and whatever. It took a long time to set up the rules. At the beginning, 2003, 2004, there was hardly any, but I think by 2007, there are a large number of CDMs, and by now there are a huge number of them floating around. The problem is what happens post-Kyoto, nobody knows. CDMs were meant to implement Kyoto. Okay, so the US didn't do any. Multinationals may have done it involving the US, but waste management, yeah, post-consumer waste. Landfills, okay, methane from landfills have largely been stabilized in developing countries. Methane. Landfill, again, big source of methane, anaerobic decay, no oxygen, the CO2, the carbon stuff decays to methane and sneaks out. And there's about 12 years in the atmosphere. Let's see, landfill, this is landfill issues. Distribution of landfill CDM projects. Okay, so here's an example where they actually had, I don't know how many projects they had though. 91 make tons projects. It doesn't say how many projects here, but. So this is the breakdown of where the money for the CDMs went, and where the projects went. I think it's in terms of, it's going to be based on whoever CERs, that must be the carbon saved or something like that, must be the units. So you can see Costa Rica, Salvador, Tunisia, Mexico, a fair amount of Central South America, Argentina, Chile, Brazil, and then Armenia out of the blue, and China. So you can see the countries sort of proposing and bothering to get these things registered, and then basically sell them to the next one. It's easy to do the waste project because there are a lot of waste handles, there are a lot of landfills, and it's easy to put a cap on a landfill, mine it for methane or whatever, so it's really a fairly cheap one. And then not only do they sell the CDM, but then they get the methane to burn. So they actually, I mean, somebody told me what you want to do is go to a business that sells CDM credits. It's amazing how much money you can make on this market, but I think it's probably going to collapse soon. It's sort of an artificial market. You can actually get paid more to put a factory in than it costs to put the factory in. Some places, it's very strange. Okay, that's our favorite one. We saw that before. Co-benefits, anything else? Not too much exciting. Mainstreaming climate change in development choices. Great title. I like that one. I'm not sure. Again, macroeconomics, forestry, okay. So I like that mainstreaming of climate decisions, reducing forestation. Oh, sorry, this one now is what policies and instruments. That is the weird stuff. So, you know, here are the list of all the things that they go through. What are the ways? What do they mean by policies and instruments? Okay. So these are the ways governments can respond. All sorts of issues. Okay, cap and trade was one. Taxes, financial incentives. Okay. Information instruments. I guess that means passing out brochures and telling people they should be doing something. That seems to. National environmental policy instruments and value criteria. Okay, these are ways you evaluate those criteria. Information instruments, sometimes called public disclosure statements, may positively affect environmental quality, allowing consumers to make better informed choices. This is the labels on your food. Okay, how many tons of carbon did it take to deliver that raspberry? Okay. England started doing it, but it was done by companies. I think Marks and Sparks started doing it in England for a while on all their food products, and they dropped it because I think people weren't even not sure that it was worthwhile. I was not sure that how accurate it was another issue. Sub-governments. So again, initiatives beyond national governments. You have subnational companies, regional states play a major role, multinational corporations, and then NGOs, civil groups. Okay, so there's plenty many ways to go after this. Let's see, too much more here. Assessment international agreements. That's not too interesting, but again, climate change other policies. That's about the end of it. So we should create that one. So again, a lot more detail, getting down to chapters. The technical summary has even more than the SPM, but again, a lot of interesting tables, a fair amount of work. I mean, clearly this one really had to synthesize a fair amount of things, because pulling together some of those tables involves an awful lot of work, because it's not just one piece of one paper that does it. Good. And last, a quick run through on AR5. Okay. This is the fifth assessment report. Scoping paper was done in Vienna last July, over a year ago. That's when the report was set out. This is Chris Field, who's in charge of Working Group 2. He's up at Stanford. The technical support unit for Working Group 2 is up there. All the co-chairs are new this year. Okay. Tom Stocker from Switzerland is doing 1, Chris Field's doing 2, and Otto Detmar is doing 3 from somewhere in Germany. I can't remember what city. So total new range. That meant the government stepped up and agreed to support the technical support unit. So the U.S. said, we want to do Working Group 2. I guess then Germany said, we'd like to do 3. I don't know how they divide it up, but That and basically Switzerland paid for working group 1. Effectively, the governments have to pay the cost of the support, basically the bulk of the cost of the entire assessment, because the technical support unit runs all the operations. So other than the travel for people, which comes out of different funds, the whole cost of preparing the volume for 3 or 4 years basically is borne by the one government. So in operations, at least I think like 2 to 3 million a year more. Do this. Okay. Oh, it was so lovely. This is the funny picture. This is a bunch of nerds in a beautiful building, and you can tell they really don't belong there. Scumping meeting. They gave us one day in this really lovely place. It's absolutely gorgeous. What's funny, I recognize half the people, you don't know them, but I recognize about half of them. We went through various things. Out of that meeting came this document. These are 3 documents as of 3:30 p.m. Final plenary on the 17th of July. Working group 1, 2, and 3. These are the chapter outlines. I'm not going to show them to you because they got changed a little bit since. So after that meeting, everybody came up with the outlines. Then it went off to an IPCC plenary. And the plenary was held in Bali, I guess, later in October that year. And this is just the governments primarily. Governments send delegates and go over the plenary saying, is this the assessment we want? So they have an outline. The co-chairs come and support their outline and present them. Not the authors or their particular whatever. It's mainly the co-chairs who sort of led it. So they go there. And these are various things. And so the only reason I bring this up is if you get fun, you can have the Earth Negotiation Bulletins, the ENBs. I told you about them. I've seen them before. This was the one from there. And every once in a while I'm laughing over what these are the notes of what happened. You can sort of read between the lines, just read how crazy it must have been. France, Germany, Venezuela, and Sweden suggest social structures and systems as cross-cutting themes or dedicated chapters in Working Group 2 and 3. So they wanted whole new chapters on social structures and systems. Okay. Venezuela called for including indigenous and cultural aspects. Austria wants uncertainty should be dealt with in a consistent manner. New Zealand, Germany, Belgium, okay. Let's see. The Norway and Netherlands supported the inclusion of scenarios as a cross-cutting theme. How do we do scenarios? New Zealand Brazil called greenhouse gas metrics. The global warming potentials were not enough. They want other metrics to equate the balance of how important different greenhouse gases were, okay? And everything else is all going, and this is the opening. This is the opening. Chair, IPCC Secretary Renata Christ introduced the documents. Chair welcomed the initial comments, and then this all starts pouring forth instantly. It's chaos. Okay, everybody raises their flag, comes up with something new, okay? Da-da-da-da. Okay, all of this appears in probably the first hour or so. And then let's see, UK wants regional aspects in the synthesis report. The US emphasized the importance of regional chapters in Working Group 2, okay. And finally, US says, why don't we get to work here? We actually have to do the Working Group outlines and not fight over what's in the synthesis report. This is not the synthesis document, this is the Working Group ones. So they finally say, let's get back to work and say, okay. So everybody had their say. And that's why reading some of these, sometimes the reporting is really humorous, because sometimes it doesn't make sense, and somebody sort of somebody was trying to get their finger in places. So anyhow, it's quite funny. Switzerland addressing uncertainty, very funny. Here we go. Chair Pachari said contact group. Okay, contact groups. That's what happens when you don't know what to do in plenary, so you send 1 or 2 people off, distinguished delegates, usually political leaders or whatever, to go off to a room and say, tomorrow afternoon you're going to meet for 3 hours and solve the problem. And anybody who cares is at that contact group. So you can't complain at the plenary if the contact group comes back and says, everybody agreed to this, if you didn't show up. So the goal is to get to a smaller group, to come to some conclusions and basically compromise within a group of maybe 10 or 20 countries that have real interest in it, and not have 190 out there waving their flags at various times and changing the subject. You can see the subject keeps getting changed. So that was a sequence of sort of interventions that were done. Okay. Near-term climate change is an issue. That's one of my favorite. That's the chapter I'm going to be working on this time, okay. Norway asked for inclusion of air pollution. That's another topic. I'm glad that got in, okay. Delegates went through the outline chapter by chapter, okay. So then you finally go through it. Here, okay. I love this one. Somebody objected to the word prediction versus projection and air pollution versus air quality, okay. These are accommodating disasters in the outline. I love this one. Switzerland with Indonesia suggested accommodating disasters in the outline. I don't know if it's the language of the reporting or not, but it's pretty funny. But the idea is, where do you list disasters? Okay, and what is a disaster? It's always been one of the tougher definitions. AFLU, okay, big hot word, AFLU. All familiar with it? Ag, forestry, and other land use, exactly what it says, okay? AFLU is the one source of greenhouse gases, both carbon and especially N2O and methane. It's sort of a sector they finally thrown it all into, is AFLU. Okay, it used to be land use changed in forestry, but that didn't include agriculture. So now they realize agriculture is dicey. all the emissions from the AFLU sector are very dicey in terms of the quantities, our ability to predict them, the quantification of the AFLU sector is bad. It's a whole problem in itself. And it may not even be included in the future climate treaty to start with because it's so difficult to quantify. Not the fossil fuel burden of the ag sector, but what the rest of the ag sector does. So it's always a hot topic. And we finally end up with our 3 final outlines. Okay, let's see, I think I listed to go through them each. So working group 1 is going to be called the physical science basis again. It's always so boring, I always call something like that. You know, physical climate change or whatever. So the working group 1, it's not very incentive. Now, the outline on the left is the one that we last did in 2007. And this is the new, totally new, inventive, meant to be restructured outline, and it starts looking an awful lot the same. Notice there's still an introductory chapter. We said we get rid of the introductory chapter, it reappeared, partly due to the co-chair. Observations is in there again. Clouds and aerosols has a separate chapter. Near-term climate change is totally different. That's a new chapter itself, as opposed to just all of climate change projections. And sea level change has its own chapter. So those things are big and different. The rest are about the same. Anthropogenic and natural radiative forcing, well, that's the radiative forcing chapter, which was changes in constituents and radiative forcing. That's for the same chapter. So you can sort of recognize them all there, one way or another, renamed, except for sort of 3 big ones that came out as being important. And then again, there's the last one called climate phenomena and their relevance for future regional change. I don't know what that means. We still have trouble. Working group 2 is again similar. There's a lot of overlap. Structure is still same, basically. Point of departure, foundations, decision making, terrestrial water. Then we get into the sectors, and then we get into the regions. Okay, so it's not that different. Except now you see a lot of this breakdown. We haven't hit regions yet. So a lot of this stuff, you start seeing human health, human security, whatever, there's a lot split out more. And then we actually end up with the regional aspects being another 30. There are 30 chapters in working group 2. It's a nightmare to organize. Each chapter probably has 8 to 10 lead authors. I mean, it's going to be mind-boggling to organize these meetings. Fortunately, there's not a lot of overlap once you have to get done, but it's just a huge enterprise. To keep it straight in your head, I can keep working group 1 in my head. I've done it enough. I've seen it. I sort of know what the pieces are doing. I sort of know what to expect. Working group 2 with 30 chapters, to think that one chapter wouldn't mess up and decide to say something totally random in conflict with what another chapter had is what somebody has to oversee. That's what the co-chairs and other people have to oversee, saying, no, no, no. You said one thing, you said another, it's wrong. We can't have that. Somebody has to watch over that. And with 30 chapters, it's rather frightening. Working group 3, similar again, energy mitigation pathways. You can see the outlines there. Now, with each of these comes, and I'm not going to do it, a detailed outline. Chapter 1 has an executive summary, which, considering having done chapter 1 last time, there isn't a lot to summarize. Rationale and concepts of the working group 1 contribution, treatment of uncertainty, and climate change projections since the first assessment report. Those are the only 3 bullets in the entire chapter. It's hard to see what chapter 1 is going to have. I'm serious. This is going to be, I'm glad I'm not doing chapter 1. It could be more embarrassing than last time. Chapter 2 starts getting observations, it starts listing changes in so it's historical. This is the climate chapter, what's happening in climate. And so you see various things listed, extreme events, tropical storms. There's nothing too unusual there, and you go through the rest of them. Oceans have their bullets dealing with salinity. There should be a pH one. Change in ocean circulation. No, pH did not make it. Acidification did not make it in this. Oh, there you go, ocean acidification. Biogeochemical changes, including ocean acidification, middle hole. So that's now explicitly in. What that means is the chapter 3 will have 7 sections or more. They have other sections. If they need to have a section to define something about oceans that they want to write up, that's fine. But it has to have these. And either they're clearly located. Governments expect there to be a discussion on these topics somewhere in the chapter, and effectively an assessment and synthesis of what's done today. So that's all the bullets mean. You can add other things if you don't steal them from somebody else's chapter. You can do whatever you want that you think necessary for the science. But you better make sure you at least answer them. In some cases, that might be a paragraph. If nothing's known and nobody knows anything about it, you say, they're not going to say for ocean circulation, but it could be. We don't know what the changes have been in ocean circulation, but they do. If there were examples like that, there could be small statements. They're just a paragraph, but you better make sure they're in there. And we go through the outlines of this one. There's a bunch new on those. Did I put? So this is all the detailed bullet outlines for everything. You can go look them up on the web. AFLU is a big mess, right? I'm looking at digital. Oh, okay. Timetables. There we go. Okay, so this is what's going to happen basically for the timing. The upper right's working group 1. Okay, that's started first. Working Group 2 is second, so the first lead author meeting for Working Group 1 is this November in China. The first lead author meeting for Working Group 2 is January somewhere in Japan. And Working Group 3 will follow, I think it's February or March somewhere, I don't know where their meeting is. The timetable, this is the closeout timetable, and I'm not sure this is currently up to date, but the idea is somewhere in mid-September there would be a final government plenary for Working Group 1 where you go through the summary for policymakers, one line by line, finish it off, and then there'll be a 6-month lag for Working Group 2 and then Working Group 3. And then another 6-month lag to get the synthesis. There's arguments that the synthesis, the more you rush the synthesis, the less it's synthesized because people have time to put them together and say, do we have any combined knowledge that's different from just pulling the bullets out from the other ones. So, in some sense, things all begin now. It's going to be quiet. Why? Because it's lead author meetings. They're not public. Okay? They're not open meetings. It's not the plenary. There's no press. I mean, the press may want to know about, but there's nothing to tell them, and you can't tell them anything since nothing gets decided until you start writing chapters and putting them in, getting reviewed, and start deciding what goes in. And so, literally, there'll be not much news on this for a long time. There are some special reports coming out on extreme events next year and one on energy use or something that are special reports that are focused. Mini reports, they're about a third the size of these big ones, and they're generally may have 6 or 8 chapters, but they're focusing on, one's focusing on extreme events and vulnerability to extreme events, and then the other will be on some energy use cycle thing that I have to pay attention to. So, anyhow, good. So, it begins again, just when you think and breathe, right? So, again, it's a funny game. Nominations got started over a year and a half ago, and then they started selecting authors. I think the authors were finally selected this spring. Around March, April, it's the first time people got, were told they wanted to submit or not. The governments actually nominate, you can nominate yourself, but the governments actually put you forward, and they're the ones who sort of say who they want or don't want. Because in some sense they're paying for them. The governments want their own government for their own people, but also they want some level of review. They don't usually interfere. If Working Group 1 says they want following people, they'll say okay. But the other problem with these chapters is to get the wealth of authors. So the list of authors gets fairly long. Chapter 11, I'm on chapter 11 this time, which is the near-term climate predictions, has something like 14 lead authors. I've never been on that many before. Just huge. I have no idea why. It's a difficult chapter because there are many things to cover, but there are a huge number of lead authors on it. So, good. Questions? Thoughts? Good. Thank you all.